Okay, guys. This is going to be the second part of the 1-3 video for Algebra 2. So I'm just going to call it special cases. I don't know that they're that special or unique or anything, but they're just different from the typical where you're like, here's a point, here's a slope, write the equation of a line. Or here's a point, here's another point, calculate the slope, and then find the equation of a line. Sometimes these are a little unique. Now, before I actually do the writing of the equations of the lines part, I want you to look at these two examples. We need to talk a minute. All I'm going to do with these two examples is calculate the slope. I want to talk about that. There's something very unique to the first actual question where I'm going to say, hey, write the equation to this line. You have to know what's coming. Okay? So, first of all, you have the slope formula in the previous video, and you should have that written down already. So here we go. We'll label this x1, y1 for first point, x2, y2 for second point. So as I go to calculate this slope, the numerator gets y2 minus y1. So y2 minus y1. You start to see what's going on here. That's an issue. And in the denominator, it's x2 minus x1. Whoops. So yeah, x2 minus x1. Minus a negative becoming a plus. And we get 2 minus 2 is 0, 5 minus a negative, or 5 plus 7 is 12. Folks, 0 in the numerator and any other number in the denominator is 0. Which means the slope of this line is 0, which means you got to think about that. Slope is a measure of steepness, like what's the rise for the run. This implies, and you can see it right here kind of, that means no rise, run 12. If I have no rise but run 12, folks, we're talking about a horizontal line. This is a horizontal line, okay? And if we think about where these 2 points are to plot them a minute, that point is 7 left, 2 up from the origin. This point is 5 right and 2 up from the origin. Folks, they're both 2 up. So they're both right here on the same level. That makes a horizontal line, and that's always going to be the slope of a horizontal line. 0. Keep that in mind. Secondly, let's go to this one. If I do the slope again here, this is x1, y1 for first point, x2, y2 for second point. Doing the same calculation. y2 minus y1 over x2 minus x1. We see an issue here. Folks, negative 4 minus 8 is negative 12. 3 minus 3 is 0. Folks, that technically says negative 12 divided by 0. You can't divide something by 0. That's called undefined. When I'm usually in class with a group, I'm usually like, here's an analogy to compare this to. Suppose you have a pizza. And you can't say something ridiculous and silly like, well, what if you eat it? Okay, so just get that. You have a pizza. You could divide that pizza into 2 pieces if you want. Cut it right in half. Half for you, half for me. That's 2 pieces. You could cut the pizza into 3 pieces, or 4 pieces, or 5, or 6, and most pizzas are cut into 8 pieces, as you well know. Can you cut the pizza into 1 piece? That answer is yes. Don't cut the pizza. Just leave it as one big slice, and you consider that 1 piece. Can you cut the pizza that's sitting in front of me into 0 pieces? No. At its very minimal, it's 1 piece. You can make it 2, 3, 4, 5, any amount of pieces, but you can't make a pizza that exists 0 pieces. And that's where you can't say, well, I ate it, now it's gone, there's 0 pieces left. That's just silliness. That's, elementary stuff. So we can't divide by 0. Now you guys, another way to interpret this is from this standpoint. This means rise because the negative, drop 12, run none. So if I'm somewhere and I drop 12 and don't run, folks, I'm vertical. And if you look at these 2 points, they are vertical if I were to plot them. Folks, this point's 3 to the right, 8 up. This point's 3 to the right, 4 down. They're both 3 to the right, so they're in the same vertical line. Every vertical slope will be undefined. This is a vertical line. So I want you to keep that in mind and put a note to yourself in your notebook. Every horizontal line, the slope is 0. Every vertical line, the slope is undefined. And we'll talk about that, okay? I'm going to pause a minute and get the real examples up here so now that we know what to expect there. Okay, folks, so I got the examples up here. Now I got 3 examples to start, and I've got 3 more to do after that. They're a little bit tricky. I'll break up and do for you. Okay, so number 1. You got to be basing this off the little slope examples I showed you last time, but just because you know a little bit about the slopes, we got to talk about now, well, how do I do the equation? Because that's weird too. So you guys, I am asking you to write the equation of a line that passes through the point -7, 4, and the slope's undefined. Now see, in the previous examples, the previous video, every time we labeled this x and y, and we labeled the slope m, and we plugged that stuff in, and we solved for b. We can't, undefined's not a number. You can't do that. So there's gotta be a way. And believe it or not, finding the equation of undefined and 0 slopes is actually fairly nice as long as you know what to do with it. Now I'm going to show you something. I know if the slope is undefined, that means vertical line. That's what that means. So let's think about this. The easiest way for me to explain this to you is to graph this line a minute so you can visually see it. That does not mean to do this question you have to graph it. That just means this is the easiest way for me to explain it, and then I'll tell you what you would normally do. This point is from the origin 7 to the left and 4 up. So I know that our line passes through that point. Secondly, this is something you have to learn and then know and commit to memory. I know that my line is vertical because it's undefined slope. Folks, vertical line would look like this through this point. So listen, because I'm about to write the equation of this line right now. There are examples in the lesson before, not the previous video, but when we were graphing equations of lines, verticals and horizontals only had either an x or a y in it. Well, look at this. This vertical line crosses the x-axis at -7. It does not even touch the y-axis. Folks, if I don't touch the y-axis, my equation should not have a y in it. My equation should have an x in it. And you know what it is? X equals -7. That's the equation of this line. My line hits x at -7 and does not hit y. The absence of the y tells that story. Okay? So in the future, if you know you have a vertical line, that number is your equation, x equals 7, because verticals only hit the x. Horizontals hit the y. Now, let's go to this one, because I can actually do this one of 2 ways. I'm going to do it the way I would like you to do, because the minute I see the slope is 0, that's horizontal line. That means, just for a visual a second, I can plot this line 1 to the right, 8 down, so 1, 2, 3, 4, 5, 6, 7, 8. So you guys, I know that my line goes through this point, and because it's a horizontal zero slope, it goes like this. So I could write that equation right now if I back up to the lesson before this, 1-2. I'm only hitting the y-axis. I'm not touching the x-axis. So my equation should have a y and no x. Well, what y is it? It's -8. That's -8 right there. So it's y equals -8. And that's that. Now, this particular one, stay with me a minute, I can do the old-fashioned method. I can say, guess what? This is x, this is y, this is m. See, because 0 is actually a number, where undefined's not a number, so the vertical undefined, I got to be on my toes, and I got to be on my game, and I got to be ready for this. But this one, I could plug things into the y equals mx plus b, and it will mathematically work. The y is -8, the m is 0, the x is 1, and the plus b. So I find out, I would calculate this, 0 times 1 is 0, that cancels, and I get b equals -8. So when I go to write the equation of the line, see, remember in the previous examples, the previous video of 1-3, you would get your m and your b and write your equation. It's y equals m x b. You guys, 0x is non-existent. 0x means no x's. So technically that's gone, and that says y equals -8. Technically, writing the answer as y equals 0x minus 8 is not wrong. I'm just saying, if you catch that this is horizontal, horizontals only cross the y equals where it crosses, -8. And it happens to be that. So you guys, verticals are x equals the x coordinate. Horizontals are y equals the y coordinate. And again, the more that you know, the easier these get. Okay, next example before I kind of close this or pause this portion of the video to get the other examples up there. Throwing a little trick at you here that I want you to catch. Now again, this one you totally have the option of saying, hey, you got a point here, 0, -7, let's label it x and y. Here's my slope m, and let's plug that in and do the whole solve for b thing. Let's listen a minute. You know that m stands for the slope and b is the y-intercept? You realize that this point is the y-intercept? 0, -7, just to use this graph as a point to point it, it's that point right there. Now, you guys, this one is not slope 0 or slope undefined, so this is not vertical or horizontal. We're off that. That's that. 5/8 is a rise 5, run 8. We're talking about a line here that's diagonal. But if I catch this, folks, this is b. Anytime the x-coordinate is 0, the y-coordinate is your b, your y-intercept, 0, -7. And you guys, this is m. You catch that? There's no work to do, no calculating to do. It is literally y equals m x plus b, -7, of course. Folks, if you take the time to plug this in for x, this in for y, and this in for m, you're going to get b equals -7 and be done. But if you catch it, and again, that's a secret, a trick, paying attention and observation. If the x-coordinate is 0, that's your y-intercept, okay? So you just need to watch for that. It's not like a super fancy special case, but it's just something that if you're on your toes, you shorten the amount of work you have to do. Okay, pause again to get the next group. Okay, guys, before we finish the examples that are on the board now, it's our last 3, we need to talk about something. So some of these examples are going to be the examples that you consider the toughest. That's kind of my experience with this. over time is that students find these a little bit more challenging, and I'm going to try to clarify as much as possible and make it as easy as for you as possible. You're going to hear mention of in the 3 examples something to do with parallel lines and perpendicular lines. Now, by definition, parallel lines are 2 lines that never cross each other. They go in the exact same direction and never intersect. Perpendicular lines, in fact, intersect, and more specifically, they intersect at exactly a 90-degree angle. That's a little bit irrelevant, not totally, but partially. Here's what I need you to know. If 2 lines are parallel, they have the exact same slope. Think about that. If they're traveling in the exact same direction and never cross, they must have the same rise and run. So that's what we're dealing with. Now, perpendicular lines cross each other. So if one's going this way, which is a positive slope, one's going this way, which is a negative, their slopes are going to have different sign, one positive, one negative. That's called opposite reciprocal specifically, meaning one will be positive, one will be negative, and whatever one is, the other will be flipped. So like if one slope was 2/3, its opposite reciprocal would be negative 3/2. If one was 3/4, okay, then the opposite reciprocal would be negative 5/4, or excuse me, 4/3. 3/4, negative 4/3, and so on. If a slope was 2, its opposite would be negative. Folks, flip 2, it's like 2/1 becomes negative 1/2. 2 versus negative 1/2. Negative 3 versus positive 1/3, and so on. Okay. So here's our closing examples now. So we need to talk about what is extremely useful information up here and what is pointless information. Folks, we are going to be kind of back on the y equals mx plus b train unless we come across a vertical or a horizontal. Vertical, horizontal, sorry. So we know that our line goes through, that's x and y. And folks, it's parallel to this line. Immediately in my brain I say, hey, parallel, they got the same slope. Meaning this slope, y equals mx plus b, their slope is helpful to me. Their slope is my slope. I'm going to label this m. That is useless information. That's where the kids are like, what's that -7? Useless information. Our line goes through that point. Our line has that slope because they are parallel to each other. There is x, there's y, there's m. I'm going to solve for b. Their b is useless to us. So here we go, using the y equals mx plus b. Y equals m times x plus b. We need the b for our situation. Useless information, and I know I keep saying that, but that is an issue with students in this example. Y equals 3 times 1 is 3 plus b. Solving for b, we always either have to add or subtract. This is not a division situation. That's a positive 3. We subtract 3 from both sides. 7 minus 3 is 4. 3 minus 3 cancels. B equals 4. The minute we have m and b on our workspace, we're ready to write the equation. There's m, there's b. Y equals 3x plus 4. This is our line. That was their line. We share the same slope. We are therefore parallel. Okay, next situation, I changed it up a little bit. We are still passing through a point. That's x and y. And our line is perpendicular to this one. That means their slope, which is 1/5, y equals mx plus b, their slope is opposite reciprocal to ours. Or ours is opposite reciprocal to them, however you want to think it. Folks, that's 1/5 positive. Our slope will be negative. Flip that over, that's 5/1, 5. Negative 5. See, that's positive. Our slope's negative. So I'm going to make a note over here. M is negative 5. Always useless information. Their B is useless to us. That's their line. perpendicular and parallel are slope. We need the slope, and that gives us the slope. Okay, so here's m, here's x, here's y. We're right in the same situation we've been quite a few times. Plug it in and solve for b. So y equals m times x plus b. 4 equals, folks, -5 times -5 is positive 25. Be super careful on that situation. That's just open for making dumb mistakes right there. We are going to subtract 25 here. 4 minus 25 is -21. 25 minus 25 cancels. B equals -21. Folks, we have m, we have b. Y equals -5x minus 21. Okay? And in closing, I have probably the most challenging example for most students. This time, we have a line that is going through this point. That's x and y, because our line's going through it. We are perpendicular, so the minute I see the word perpendicular or hear it, I'm already thinking, hey, opposite reciprocal slope, that's what I need that for. But look at the given information this time. Perpendicular to the line that goes through these 2 points. So listen, this is very careful, very critical. Those 2 points at the end of the problem are there for one job and one job only. Calculate the slope, and then do opposite reciprocal, and I'm done with those points. They're useless to me after that. So when I do this in class, I usually label this x1, y1, x2, y2, and I separate the workspace and say, this is extra business over here, and then I'll go over here and do the real work. Folks, we need slope. So y2 minus y1 over x2 minus x1. Folks, please notice, as before, if I have a minus and negative, I change it to plus. That's right here. Okay, 5 minus 6 is -1. -1 plus 4 is 3. We got to pay super close attention right here. The slope of the line that goes through these 2 points is -1/3. That line is perpendicular to ours. That means our slope is opposite reciprocal to that. So opposite meaning positive. Flip that over and it's 3 over 1. That's 3. Our slope is 3. Folks, this over here is done. I do not use these 2 points anymore. Folks, those 2 points are not on our line. We cannot use them anymore. They were strictly in the question for slope. So those 2 points are out. I used them for what I needed them for. I got slope. So here we go. We're back. We've done this a bunch of times now. Here's an x, here's a y, here's an m. That's the proper m. You get the wrong slope and the whole problem falls apart, right? Okay. So here we go. Y equals m times x plus b. -3 equals, multiply these two, 3 times -8 is -24 plus b. Folks, we are going to add 24 right here. -3 plus 24 is 21 equals -24 plus 24 cancels b. B is 21. As soon as I have the m and the b for that line, I write the equation. Y equals m x plus b is 21. And you guys, that closes out that lesson. Okay, that's the and I know that's a lot of videos to video to watch because I did it in 2 parts. But these special cases take some time, and I don't want them to stress you out. I want you to be like, I get that now. I get it. Anytime they use the word parallel or perpendicular, it's a hint at the slope. Parallels have the same slope. Perpendiculars has the opposite reciprocal slope. It's just there for us to use for slope. All right, take care, you guys.